some people have already done the Scala or some has done Python. But whoever interested, they can follow any one, okay, at a time. Mm. So either you can follow completely Spark, Scala, or otherwise PySpark. Okay. Okay. So I will tell the repositories. I will tell you can get the source code. Can get the source code PySpark by example. So they have for the Scala repository as well as the Python. So you can so you can check here. This is the PySpark repository. So all the Spark examples are here. So you have to import the project in the PyCharm. So last time I or not. So I will show that PySpark like how to configure and how to import the project, and then you can start practicing the the examples. Okay. So okay, I just give first basic starting of the Spark, and then you can start practicing the example. So mainly the Spark core is a transformation. So we will see the Spark core as transformation and actions. So transformations are nothing but the transformations are functions which are converting one form to another form. So we can say RDD, data frame. These concepts will come. The transformation is nothing but functions of conversion, right? Converting one form to another form. So it could be there are so many transformations are there. Okay, map is there, flat map, join, filter, like group by key, reduce by key, group by key, reduce by key, union, right? So these are all transformations. So you can do practice of these transformations in the examples, reduce by key. And there are some actions also there. So action is giving a final result. So the definition of the action is which is giving final result. We cannot do further any transformation. So those are the actions. And basically when action is called, then only transformation will be triggered. So Spark is the lazy. Okay, I will tell about this. So action, some action are like for each. For each is a action, for each is the action, count is the action, select is the action, okay, and take is the action. So these are the actions. So Spark is lazy. So when we talk about Spark, Spark is a lazy, and because why is lazy? Because it is not loading data immediately, immediately in memory. So when we trigger action, we trigger action, then it will load transformation, memory, and process. And process. It will be giving final result. Action will give final result. Okay, this is just a definition about what is transformation, what is it. So Spark, first we come to know why we go for Spark, right? Already we have other analytics frameworks like Spark versus if we compare with the MapReduce versus Hive, okay? So MapReduce and Hive, these are Hadoop based component, okay? So MapReduce and Hive, these are Hadoop based file system component. So these are especially batch processing, and batch processing, like historical data processing. Like large amount of data is there and which is stored on Hadoop file system, then we are processing, doing using that. And the other the drawback is there in the this MapReduce and Highways, um, like intermediate output data, like intermediate output data, because it's a steps of processes are there, right? Because it's not a only one action, right? When we are doing a job, right? Job is having set of tasks, right? So if I say one task is completed, the intermediate output data is stored in this. Okay. Again and again is read from this. So this kind of processing is there, right? So it is more IO consuming, right? More time IO consuming, right? Input output consuming, processing, consuming process in high when mapping, okay? High when mapping. This is the one more drawback, okay? Because it is more time, because the jobs are not faster. The jobs are not faster in mapping. Because it is backend is a MapReduce, okay? And I say, and the MapReduce you need to write a lot of code. Okay? You need to write lengthy Java code. But on the other hand, Spark is first of all is in-memory computation. In-memory computation like faster 100 times faster in memory. So if I talk about how much faster is in memory, 100 times faster in memory as compared to MapReduce. Okay. If I say dash, if I say 10 times faster in disk processing, 10 times faster in disk processing. Okay. So if you are processing the data in memory, it is 100 times. Okay, but it's still the 10 times faster in the disk processing. Okay, so Spark has the advantages in memory computation, and it is like if your job got failed here, so one more drawback, if your job got failed, it will start from the scratch. It will start from scratch. Okay, because there is no DAG maintained. Here is Spark having DAG, direct acyclic graph, direct acyclic cyclic graph, which help it help like if any time computation got failed, any task is failed, task failed, so it will not start from the beginning. Job got failed. The job has the multiple tasks. The job failed, so it will not start. Okay. So that is the reason why we prefer Spark. The Spark is in memory computation, and Spark doesn't have dependency on Hadoop. The Spark doesn't have dependency on Hadoop. Okay. You can run a Spark job standalone. Spark job can be run standalone. Standalone means you can run independently the Hadoop file system, because if you want to process the data in Hive and MapReduce, you have to bring the data in Hadoop file system. So that's a drawback. So now if you are going to start the Spark, okay, so we need to understand Spark fundamentals, like core concepts of the Spark, right? How many modules are there, and multi-language support is there, okay? So there are many number of advantages are there, right? Here, Spark is multilingual. Multilingual. So it is having Scala, because Scala is a native language. Scala, Scala is native language. So it is, this is the reason it's faster, because Scala is a native. So Scala, Spark Scala is better, much faster than the PySpark. Okay. So Scala is the native. So Scala is there, Python, R, or Java. So these are the different languages support is there. You can write the APIs. You can write the code. And Spark has three data structure. So these are the three fundamental data structures. So data structures are the building blocks, right? We say in Java or any programming languages, what are the data structures? We say Like in Java, we say data structures are list is there, set, linked list, right? Array list. Okay, those are the data structures like building blocks, right? You can write applications through collections. Okay, so you say these are the data structures, right? If I say in the Spark, the data structures are RDD data structures. So data structures like RDD. RDD is a fundamental unit of the data measurement, right? Like you first you get the data as RDD, right? Whenever you are reading data in Spark is the RDD, okay? But it depends like what type of data you are reading, okay? So RDD, data frame, and data set. So we should know the clear difference between these three because this is very fundamental questions like people ask, what is the difference between the RDD, data frame, and data set? Okay. So RDD is, when we define the definitions of RDD, it's the immutable, immutable collection, immutable distributed collection of data, which is spread across worker executors. So here new terms coming executors. So executor is actually performing the task. Executor. So we know master and worker node, right? So master is where the driver program is running. Driver program is running. So we already aware of driver code, right? In the Java MapReduce, you have seen the driver. Okay. So driver is a starting program where the execution will be started. So where the driver program is running, okay, it's the starting point of your application. Okay, starting point of your application. Okay. So when we come to worker, right? The worker is also node, right? So workers are having the nodes like machines, like we are talking about the data nodes in terms of Hadoop, or if I'm saying that the general machine is there as a node, right? So nodes, right, we say have the workers are nodes, and nodes have executors. So we know in the terminologies, in the hardware terminologies, we say we have machine, and machines having the CPUs, memories, and disk, right? These are the three common terms we call it, okay? But apart from that, we say like CPU has cores, right? CPU cores we call it. Memory we say like if it is a master driver program, so driver memory is there, okay? If it is if it is a worker node, so worker node having executor memory because executor having executor core and executor memory. So your total cores will be divided like your CPU cores, every machine CPU cores are divided right in the executor core. Like suppose you have a 5 cores machine, 16 cores machine, and you have four executors. So four cores will be given to the each executor. Okay. So this is like a tuning, right? We do. Okay. So I will talk about more on that. So I'm just talking about high level, right? What are the types of resources are there for executing the job? So these are the all internal resources for performing the job, right? So driver memory, executor memory, and executor cores. So executor cores and executor memory. So two things are there in the worker: executor cores, executor memory. Driver is having the driver cores, driver memory. Like the CPU cores is basically depending on the machine, right? Whether it's a driver machine or it's a worker machine. Okay. So here is when we talk about RDD, it's a immutable. And each executor performing task. So I come to first architecture of the Spark. Okay, so RDD is the fundamental unit of the Spark, okay, because whenever you are reading data, it comes RDD. But what type of data will become RDD and which data will become data frame? Second one is the data frame. The data frame is it's a tabular representation of the data. Yes, tabular representation of data which is in form of rows and columns. Rows and columns. Okay. So when I say I'm reading a data, I'm reading data of data for files like CSV, JSON, XML, where the some schemas are defined. Schemas means the columns, right? CSV we know, right? We have a specific columns are there. Okay. JSON we have key colon value is there. XML we know, right? XML node is there. Like root tag is there inside the root. There the elements are there. So all this XML is defined. Or some SQL database data. Okay. So this type of RDD doesn't have the schema because RDD is unstructured data. So suppose if I say this is a text file. So when you read this text file, it will read as a RDD. Even JSON file you can read as a RDD. But for that, right, if you don't pass the schema, you will read as a text file as a RDD, even JSON file also. But generally JSON or XML or CSV, these are already schema is there in the file, right? You say like key colon value you are saying, right? Your data is a key colon value, key colon value.
हाँ 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 हाँ
So key colon value data is there. So that is the reason schema is defined. Like XML node are there, right? So we know this is the root element, and inside root there is a employee ID is there, employee name is there. So like you are defining the XML like this. Okay, EMP tag is there. Then you are saying EMP ID. So what is the schema here? EMP ID is a schema, right? It's a column name, right? You are getting the column name. Okay, and you are saying the value is 34 here. Okay, and you are ending the EMP ID. So this EMP ID you are repeating, right? If you are defining another EMP tag, you are saying another EMP tag, again you are defining EMP ID. Okay, but if it is an unstructured data, so any file you can read as a unstructured or any file you can read as a specific kind of file. Okay, but this is only applicable for CSV, JSON, XML. So CSV, JSON, XML file you can get the data frame, but this kind of text file data you can't get the data frame. So text file is always RDD. If I say RDD is can be anything. It could be a text file as RDD, CSV file you can read as RDD, JSON you can read RDD. But in that case, what will happen? Entire text as a coming RDD, there will be no schema attached with that. Okay, so you have to read. Suppose you say, well, RDD spark dot read dot text file. If you use this function and you say here test.txt, or you say test.csv, or you say test.json, right? So any file you are giving, you can read RDD, but you have to do operation row by row because RDD is not a column oriented, okay? But data frame is column oriented or tabular representation. So that is the reason we always say whenever we have CSV file, JSON file, so the data frame is the best option. Why the data frame is the best option? If the CSV file you are reading as a data frame, okay, like CSV file, so you are reading like this, well, df spark dot read dot CSV, or you can say dot JSON, or you can say dot XML. You just change the method name and you can read that particular type of file. Suppose you are saying test.csv, test.json, okay, test.csv, test.xml. Okay, so here you are able to read any type of file. Any type of file you are able to means CSV JSON by their specific methods are there. You can read. Okay, So you can read either test.csv, or you can read the test.json, or you can read the test.xml. Okay. So if you are reading test.csv, it will be read as a tabular representation. CSV file become as a table. JSON file you are reading, it will become as a table, as a data frame. Okay. If you are reading XML file, you say test.xml, it will become XML, like you say emp id, emp name. So your data will be look like this: emp id, emp name, and emp age, like this, and then value will be coming. Okay, emp id is 34, emp name is a test, emp age is 23, and this is another record: 56, test 1, and 45. Okay, so this data was in XML like this, but when you are reading as a data frame, it becomes like this. Okay, so and if you say, okay, I want to read a text file as a data frame, so there is the spark.read.text function is there. So if you read like dot text, so it will be, you can read the text file also as a data frame. Okay, if you read the test.txt file as a data frame, so what will happen? So entire text file, this entire text file will come in a one single column. Okay, because there is no fixed schema. So what Spark will do, making it as a data frame, it will write this entire file content, like this text file content, in a one column. Okay, but for other one like CSV, JSON, XML, it will make it separate column, because the schema is there, right? Because columns are fixed, right? JSON, you know, fixed column is there. XML is having fixed column, right? You are repeating these three columns again and again. JSON, you are repeating again and again. CSV, you are repeating again and again. But here is no fixed column. If suppose if I talk about, this is a text file only, right? And this text file is no schema, like here is a 20 column, here is a 5 column, here is a 3 columns. So how is the schema fixed? But if you say, okay, max number of columns are here, I will create a one schema. Okay, then you can distribute the data. But again, you need some delimiter character. But here is a delimiter character is not fixed, right? Somewhere is a comma, somewhere is a space. So suppose you take space. So space wise, it will make it separation. So one separation is here, one separation is there, one is here, one is here, and this will all come in a one separation. Right? So wherever space is coming, it will break the column. It will break the column. Okay. So RDD is like unstructured. So generally we say the ideal way is classifying. We say if the text file is there, which is completely unstructured, we go for RDD, only RDD. If the file is JSON, CSV, XML, we definitely go data frame. That is the ideal. But there is no restriction, right? If you want to say, okay, I want to read CSV file, JSON file, XML file as RDD, you can read by this text file function. Or you say, I want to read text file as a data frame, so you can read spark.read.text. Okay, so this is the difference only. Here is a text file, here is a text. Okay, but here is the only single method is there in RDD. RDD, there is no different method is there for CS, because RDD has given only one unified function. Whatever type of file, you take it as a RDD. But for data frame, they have given a separate function. If you have text file, you can do the text function. If you have CSV, you take it. But this text file means entire data will become in one column. Okay, so you can further write get all the words right into one. So this further you can processing you can do, but initially you have to read the data. And the third one is a data set. So data set is basically it's object oriented style of programming. Okay, and it is an extension of data frame and RDD. So mostly we are using RDD and data frame only, but data set also we can use when we define entity base. Like I have a different entities are there, like EMP entities, department entities. So I can easily say, okay, this is my employee object, this is my department object. So I can read as a data as an object. Okay, so it is it is basically extension of, so it is having the feature of both RDD and data frame. So RDD is completely unstructured, and this is like a, it has both the features are there, and other thing is it is using encoder. Encoder is basically type strict. It's very type strict. Type strict API. Type strict. So type strict means like if I have an employee entity, I cannot save anything else in the employee. I will save only employee type of object. So if I say here EMP type of object is there, so only EMP properties it will take. EMP ID, EMP name, EMP. If I say it is a department entity, okay. So if you have a department, the department entity will take department ID, department name. So entity based like classification you are doing, like you want to read the data, okay. Like suppose some you are reading the data from file and you can convert to the data set. So data set is you are not reading directly. You are not reading directly data set. So you have to read the data as a data frame or RDD. But there are the conversion are there, right? Suppose you say, I have a one data frame and I have read the data spark dot read dot CSV and some employee dot CSV file I read. Okay. Now I want to convert this data frame to the data frame to DS. And then I will say here, I will make it MP something like EMP class. Class type of restriction is there. Like I want to say whatever data I'm taking from this data frame to data set I'm creating, this is a DS object. So I'm creating a well DS, some DS object I'm creating. So this DS object, data set object means this is the type of EMP only. So it is very type strict. Okay. So type strict advantage is right because you cannot assign any type to any other type. You cannot assign. So data set, but data set rather than we do the like we do mostly on the RDD and data. Okay. So this is the difference between these three. And one more thing is in data frame is not compile time safe. Okay. So data frame is not compile time safe. What it means? Suppose I say I have some data frame column is there. I say my column name is name. Okay. Okay. And I'm just going to read the data. I say df dot select. I say df dot select, and I am just writing like this: column name, column age, and then I want to show the data. Show means it's a function to represent data as a tabular structure. Okay. So when I say here the name is, I by typo I typed it name one. Okay. So you will not get the error at the compile time. That's a drawback, right? You when you are executing the program, then it will say the analysis exception you will get. So you will get the column cannot be resolved. Okay. So name one column cannot be resolved. Cannot be resolved. So what resolved? So what will happen, right? When it is doing this operation, so it is checking in the existing data frame. Here is I have name column or EMP name column, but I'm giving a name one. So that means it's not matching, so it cannot get the data from the data frame. So whatever data frame I read, this data frame I cannot get the data. Okay. So that is the reason it will be giving error at the runtime. Okay. So that is the drawback in the data frame. Okay. So data frame is not able to identify at the compile time. Okay. When you run the program, then only you will come to know your column is wrong. And then you can correct it. So that is the reason, right? We should always use manually. We should not give the column. We should read the columns programmatically, like df dot columns. When I write it like this, df dot columns, I will get a list of columns. List of columns. So it will be giving a list, and that list I can iterate and I can assign the column. Okay. Okay. So this is the I talked about the data frame, data set, and hunting. And Spark has different modules. Okay. What are the modules are there in the Spark? The Spark has a Spark core module, that is the base module. Spark SQL module, Spark streaming module, Spark graph module, and Spark machine learning ML module. So last two we were not using the data engine, right? Mostly we are not having any work with the machine learning, so then we are not going to use it. And graph is like related to um, like social media's kind of data is there, right? Like, okay, users of users and users of friends, friends like, okay. So that kind of relationships are there, we go for graph. Okay. The cyclic dependency. The cyclic dependency is one is depend to another, another is depend to the first person. So these are the three modules, like Spark core is a base module, and this is the base module where we use the transformation selection. I already talked about that transformation selection. So here the new terms you will see DAG is there, direct acyclic. And Spark SQL is reading data from the data sources, right? So reading and writing data, reading and writing data from different data sources. What are those data sources are there? We have a file system, like CSV file, JSON file, XML file, and we have SQL databases, right? SQL databases. We have MySQL, Oracle. All are the same type, MySQL, Oracle. So we can read the data from the SQL DBs. We can read the data from the file system. We can read the data from NoSQL databases. SQL databases, NoSQL databases, Mongo, Cassandra DB, Mongo, Cassandra, HBase. These are the NoSQL databases. Some Elasticsearch also NoSQL database, Elasticsearch. So these are the different source and same are the target. Same are target. So source can be anything. So we are writing ETL pipelines, like we are developing the pipelines from the scratch, reading data, ingestion data, and then we are performing the transformations on data validation. So before transformation, we are doing the data validation check, data quality check. Okay. So we'll see that how to do in ETL pipeline. So but I'm talking about the SQL module is completely related to data ingestion or data writing. Okay. And the core is completely related to transformations, right? We are applying the transformations, different conversions of the data, right? How we can transform the data, right? Because we sometimes we are reading data from source, we are not exactly writing the same data into the target. We need to modify the data. We need to transform the data, right? Okay, so we go for SQL module. Okay, the streaming module is when we are using real-time data, right? So Spark is not only processing the batch, Spark has real-time and batch code. Okay, so Spark is using real-time and batch code. Okay, so that's the benefit of the Spark. Okay, because in Hadoop and Hive of these batch processing, but here is a real-time and batch code, real-time and batch. So if I say which part is the batch processing in Spark, so SQL is a batch because all the data is coming from the historical data or coming from the different data sources. So these sources are already have the data. Okay? So this is a batch processing. And real-time processing is in the Spark is the streaming module. Okay, so real-time streaming. The real-time streaming data, so what are the sources are there, like REST API. So REST API is there, or some social media like Twitter, Facebook can get the data. Or we can say, right, some real-time streaming data, right, cricket match, for example, live cricket match. Okay. So live cricket match, you are getting the updates, right? Every seconds you are getting the updates, right? So that is the real-time data. Or you can say banking has the credit card swiping data, banking, credit card swiping data, swipe. So when you are doing online shopping, right? So this is all real-time data. So whenever this type of data is coming, so we have to use like streaming APIs, okay? Because the batch is only for batch and streaming is for streaming. So there is a streaming module is there, the separate module is there, and you will be using the streaming. But streaming is, so I told you three data structures are there, RDD, data frame, and data set. So streaming is itself is using, see, streaming is nothing but a sequence of data, sequence of data. This sequence of data could be anything. It could be a sequence of RDD. Okay, it could be a RDD or data frame. Okay, so two types of streaming are there. One is sequence of RDD, sequence of RDD, and that is called D stream. Okay, and one is sequence of data frame, that is your structured stream. So we will see that like what are these two types. But ultimately, streaming is also a kind of the fundamental data structures only. Okay, either RDD of the sequence or data frame sequence. Okay, so we believe right, the data frame is much easier than the RDD because the transformations are not easy in the RDD, because RDD is a row by row format, right? Like the row oriented format, we have to apply transformation. But data frame is a column oriented, right? Whatever transformation, the transformations are same. When we are talking about the transformations like map, flat map, filter, same transformations are there in RDD, same are there in the data frame. But the difference is here we are going, RDD's transformations are row by row and data frame transformations are column by column. So column by column transformation is much easier than the transformation on RDD. Okay. So these are the five modules. Okay. And when we start the Spark, okay. So first thing is like a Spark installation site. Okay. We need to download the Spark zip, and we have to extract or tar file, whatever. Okay. And then we have to extract it and keep it in the software. Extract it and keep it in software. Like already we are using software folder. And then we set the Spark home path. So two path we have to set, Spark underscore home, so Spark home directory, and bin, and the path. The path we set the bin path we have to set. Okay. So Spark home slash bin, that we have to set. Spark home slash bin. So this we have to set it in the bin path. So we already know how to set it. After that, you will now how many ways we can write the program. Okay, how many ways we can write program, because Spark is need an infrastructure, right? Spark needs like first is the development part. So when we are talk about the development, right, because Spark is a program, whether you are write a program in the Scala, Java, Python, everything, anything, so you have to write a development, you have to write some code. Okay, so development can be done in a different way. Like one is like you can write program in IntelliJ for Scala, Spark Scala, Spark Scala program, in Spark Scala program, and then create a project, create a like you have already write a program, create a project, and this project you create a jar of the project. You already seen in MapReduce same way, we create a project jar and then we do the Spark submit. Spark submit, and then you give minus minus class. What is the class name in your code jar and your jar name? Okay, so this is the way for Scala. This is for Scala, Spark Scala code. Okay, but suppose my program is PySpark code. Okay, so you write code in PyCharm. So PyCharm ID already we got set up, right? PyCharm, and there you can write a Python Spark code. Python Spark code, and here is no need to create a jar. So same like a Spark submit program. Okay, there is you can define your py file. Like suppose my py file name is a test.py. That's it. Okay. So this is the way for development. Another way, like you have a testing you can do. Okay. Testing you can do by either Spark hyphen shell to start Spark shell, or this will bring the Scala shell. It will bring the Spark Scala shell. Second one is when you type PySpark, it will give you triple greater than sign. Okay, like this. Okay. So you will get either PySpark shell or you will get the Spark shell. It's an interactive shell. Okay, you already know Python interactive shell where you can write a Python code and you will get the result. So immediately. So interactive shell, you can write code. You have already seen the Scala shell also. Okay, like we have practiced in the Scala. So similar way of Scala shell, there is a Spark Scala shell or PySpark shell. So difference is in PySpark or Spark Scala shell, you can do either normal Scala or Spark Scala. But normal Scala shell, you cannot do the Spark Scala. Right? So vice versa is not true. Okay. But Spark Scala shell, you can do either Scala or Spark Scala both. Okay. So you can do interactive shell, you can write the command and get result immediately. Okay. Result immediately. Okay, so this is another way for testing purpose. Generally, we are not using the real-time development way. Development is either we write a code, okay, and testing one we can test. Just I want to test my code in the Spark Scala shell, so I will just test it. So this is so you should install the PyCharm. So PyCharm, I told like PyCharm community is there. The PyCharm community you can download PyCharm. This community in download PyCharm ID. PyCharm community you can download here, PyCharm community edition. So this one you can download for Ubuntu. If you have Windows you are doing, so this one you have to download Windows exe, or if it is a Linux version, you can download the tar file. Okay. No, for Windows is this one you have to do, because this is the professional edition. So this is the trial version. But this community edition you will be you won't have any trial. You can use it permanently. So once you set up this PyCharm, so PyCharm you have to, if you want to run any PySpark code, I'll show you that how to set up the PySpark code and you can run. So this is a repository I told, right, for practice, right? So we should know Python first, right? Because without Python or Scala, we cannot do any Spark Scala code or PySpark code. Okay? So this is PySpark repository. Another one is the Spark Scala Spark by example. Spark by example, Spark Scala GitHub is there. So this GitHub is all Spark Scala example. So this one you see SRC main project. So this one is complete Spark Scala code. The RDD code is separate, data frame code is separate, data set is separate, right? So you will get the code. So it is like easily you can first understand the code, and once you understand code, you can start writing your own application. You can start writing. First is so if you want to do Spark Scala practice, so IntelliJ you download, normal IntelliJ. That is also community edition is there, IntelliJ community edition. So if you go to the IntelliJ, this is the IntelliJ idea. So this is the IntelliJ and this is the PyCharm. Both are different. So this is the IntelliJ, so you can download IntelliJ. If you are writing the Spark Scala code, if you are writing the PySpark code, you download the PyCharm community edition. Okay, so you first you start with the editor because editor will give you and like you can import the entire project and then you can understand code. Like you start one by one from the RDD code, right? Okay, we will see that how to read the different files and how to do transformations. So it's a completely programmatic code, right? Like okay, we are going to write step by step, right? We are writing the Scala code or Python code, PySpark code or Spark Scala code. So we are using the APIs of the Spark Scala. So what type of programs generally people ask, right? Like suppose somebody will ask, write a word count program. Okay, write. So suppose I say write word count in Spark Scala using RTD and data. So when I say what count program I want to write for RET and data frame, so initially you need some file, right? You are doing the word count. Suppose you say you have an input.txt file. You are creating a first, this is Scala code. You are creating an object, and the object you have a main function, and you are reading the Spark session, right? You are creating a Spark session, and you are reading a text file. You are reading a text file, input.txt file. So you are applying the flat map first, and you are separating all the word in the file with the space, and each word you are counting one and applying the reduce by. And finally, once you get the count, then you are applying the save as text file as well. As the RDD you are writing as a file. When you come to the data frame, same thing, like here is the, I told you, right, here you are reading as a text file, you are reading as a text file function you are using. Here you are reading as a data frame, text file using the spark.read.text. And here I'm getting as a type of string data, right? I'm entire lines I'm reading, line by line in a single column I'm reading. And when I'm reading as a single column, this is a one single column. And that column I'm applying as my flat map function. Okay. And flat map function, what it will do, it will distribute the line, it will split and make it words. And then I'm doing the grouping. So here is a group by function, here is the reduce by key function. So here is the map function I'm doing, which is making it every word is a one count. You remember, right? This is the map reduce program logic, like map function and reduce function is the aggregation of the word with the same thing. But here we are doing we have column and column name is a value. So one column name is a value. Okay. So here is, I'm just applying all the transformations in a one single column. So column by column, I'm doing transformation. Here is a column wise transformation I'm doing. Only one single column I'm doing transformation and I'm doing count function. But and that column data frame, this is again data frame. So whenever you are doing any transformation on data frame, again you will get data frame. And this data frame data you are saving as a in a file. Okay. And here you are doing RDD here, and again you are getting RDD. So, and finally you are writing RDD as a. So let's see these two examples and understand, right, how the code. Okay. So both the things we need to know, right? RDD or data frame, right? How RDD works, how data frame works, and how exactly we do the. Okay. So I have already set it my on the Spark home, and I just show you once. Okay, so you can get the idea. Nano back also. So if you see my Spark home is there. So if you look at here, this is a Spark home. My Spark home is in the downloads folder, Spark 3.3.4. So I have a my Spark home. Okay. So this is my Spark home. So I'm starting Spark shell like Scala one. Okay. You can write code, same code we can do in the PySpark also. Okay. The point is to understand the logic, right? How to write a logic. So and this logic you don't need to mug up. Just try to understand logic and just try to do write your own. Right. One, two time you just look at the code and try to practice to write the code without looking at the code. Okay? So then you will understand more. Okay? So just take an example like, okay, I'm going to read some text file here. Okay, let's see some text file I take. Here this text file I take. So this one is unstructured data, right? Okay. So this is the countries names are there. So I want to do the word count on this will be a good example. Okay, there are many countries names out there. I want to do word count on this. And this file name is XYG. The file name is XYG. And this is in the home directory, my user home. So first I will read the, so you know, right, in the Scala we use the val, right? Val and var we use. So val RDD spark dot read dot text file. And I'm reading from the local file system. So file colon triple slash home slash admin slash x2. So my file is located in this location. So I'm giving a. So you know, right? Whenever you are creating this RDD, it is not doing actual operation. It is just keeping it this operation as a state in a DAG. Okay. But when it will be triggered, when I do rdd.count, I will do, then I told you that, right, the all transformations. The text file is also reading the data, right? So when I do rdd.count, now it is showing me 36,626. So it means it's showing me the number of rows. Can you see here how many rows are there? Is it correct or not? 36,626, right? So this is coming total count of rows. So number of rows I got it. I did, this is the action. This is the action. Okay, but our task is to find the total word count, like word count, different word count we have. Okay. So now I will have a RDD and I will apply first flat map. Flat map when I'm applying, just remember this is the first letter word is small and second word like first letter will be capital. That is the convention. And now I have to use the lambda here. I will say x is my lambda. I say x dot split by space. So space means I have to give the like this I can give, or otherwise I can give double slash s. Anything is fine. Okay. So when I'm doing this, and if I apply the count, what it will come? It will come 36, 626, or it will come more. Can you tell me? Yeah. So what this flat map will do? It will give me just this same. It will give, or it will give some more count. It will give. What will you give more? Right? It will give more because it's a flat map.
You'll give me more. Give me more because you're flattening the files. And you get more lines. Yeah.
154,817. Right? It's giving total number of words count is given. So you can say after splitting by space, all the word in a one single array. Is all word in a single array is done. Okay. So if I do collect, right? If you do collect here, collect will be action. Count is also action. Collect is action to retrieve all the words. This is the 164,817 list. This is the list. It is coming dot dot dot. It is not giving the entire list, but it is giving all the word list. Okay. So that is the count of. This is the count of that entire this array. So it is a total number of words you can say, but still I'm not able to find my each individual like country word count. Okay. So that I have to do. So what I will do, I will not do the count here. I will do map. The map is again I have to use lambda here, x, x, and I will make it pair x comma 1. Okay. And again I will do the count. So this count will come again same because map is basically one-to-one operation. So how many number of element in your RDD like 164,817. So after applying the map also you will get the same number. So if I do this count, again it's the same because map is only difference is if I do collect here, so you will see what is coming. Every word China, so China comma 1 will come. United States comma 1, India comma 1, Indonesia 1. How many times words are there? 1 is coming. See, this is 1 is coming. So just I have transformed my this RDD I transformed to the map to this RDD. I applied map and I converted into this. Right now, next what I'm going to do, I want to find, right, the same things we generally do in map reduce also. Okay? So now I have to aggregate the similar words like China is coming here, China is coming here, United States is coming here, United States is coming here, right? Okay, here. So I want to aggregate the same key together. So there is a reduce by key function. So reduce by key and underscore plus underscore. Okay. Like at a time, it will take a 2 count, 1 and 1, and then make it 2, and again take the another element. Then 2 plus 1, 3. 3 plus 1, 4. Like this. Now again, if I do count, flatness. can like entire code if you want to paste because can hold it. Count we got it. This one. Count we don't need to do. Okay. So reduce by key will be giving the value. So I will be writing to the so I will be saving as a file. Want to write the content to the file. The counts I want to write in some file. Okay. So I have written my output into the text file because this reduce by key is doing aggregation itself. I don't need to do count. Count we needed in the data frame, right? When I do group by operation. So when I go to here, I will find RDD output. This is the folder I created, and there are the two files is created, part 0, part 1. So part 0, it is coming RTD form, this one is coming. This is the country's account, and this is the second one which has the other country. So if you want to do the data frame, so once you read the data as a data frame, so first you have to read as a one single column you have to read the data. So this particular code, like you are reading as a complete input.txt as a complete data frame. So so you are reading a text file. This is the file we are reading. This is we are reading here. And after that, we are splitting with the space and group by. So value will be a column. Okay. So that will, okay. Let's see one by one. First. Now text file is a data frame. So it's coming as a single column data frame. When I say text file dot show, it will be showing me 20 records. It's a one single column. So entire text file data came in a one single column. Okay. And it's a data frame. And now in this data frame, the value is a column. And when this column, I will be doing group by operation, the value. So I will get the, when I do this one, group by value. I will be getting, when I do group by, when I do, again, it's a data frame because data frame, you are doing any operation, it will give the data frame. When I do show, now all the word is coming in a one single column. The column is same. The difference is now the column has exploded. The data is exploded into multiple columns because I use the flat map. The same job is doing flat map here, right? And after that, I apply the group by. The group by, what is doing? It is keeping it when you apply the group by. So all the word will be like which is the same key together. But I have to apply the count function because if I don't apply the count, I will not get the actual count word by word. Okay, so that I have to do when I do this count function, and after that now I do counts dot show. So I will get the word and corresponding count. sometimes this space is not able to. So this same thing we should come down here, right? And one more thing. The same thing we are doing here, right? Group by value and dot count. Same thing I'm doing here. Right? Group by value to count. So it is not doing here. Whatever data we are reading, let's see this one, what is coming. So check only this one. My DF name is, whenever I'm reading a text file data, so my DF name is text file. So text file, my DF name dot platinum line HF words dot show. So now I'm getting all the individual words. Okay, so till here I done. Till here I done. Now I do the group by and then count. Okay. So this is now two columns are coming. So count dot show. I'm getting this is the actual operation I'm doing. Text file is a data frame dot platinum I'm applying, and I'm separating the lines with the space platinum I'm doing, and is everything is happening in the one single column only. But when we apply group by and after that we apply count, so automatically the two columns will come. So group by value, so value will be there, but one additional column will come count, because count is the function. Okay. So further, if I want to do like, okay, count, I want to do where I say the data frame is easy to do. The count is, I say where 1 8 3 1 2. The values of which are count is greater than dot show. So you will get these are the greater than 8 1 8 3 1 2. Okay, so count we can apply the the function, right? This where clause or filter. Filter also same. Filter you can do, or where you can do. Filter also like same thing. Like a filter only. Okay. So need to understand, right, the basic transformation. So if I open my IntelliJ, I show you the Spark Scala code. So IntelliJ, go to bin directory and start here dot slash idea dot. So here is like if you want to start from the new scratch project, so just take it project from the get from VCS. Okay, VCS is the control version. Okay, so you just take the location, right? Like what is the GitHub location for your code? So like this is Spark Scala code, and this code has this is the GitHub. Okay, so if you don't have the plugin, it will ask you here the plugin is not there, so it will ask you. If it is asking you plugin, so it will ask you here to install. Then you just click on the install, it will install, and then it will be bringing the project in your IntelliJ. The entire project code will come in the IntelliJ. So same thing you can do for PySpark. So once the code comes, entire code will come here. You can execute the code. Then run individual. All are the main classes. So you can run directly, right click and run the main object. Because Scala we are using the main object. So you are getting this is a list of the codes are there, right? Reading the CSV file, Spark RDD transformation, pair RDD function. So this all are the right. So RDDs we can do another second way of creating RDD is by using the parallelize function. So there is sc.parallelize, Spark context.parallelize function. You can get the data as a RDD. So one is you are reading the spark.read.text file, you are getting RDD. The second way is RDD is you are getting the file as a parallelize. You are using the parallelize function. So if you pass any collection name in the parallelize, right? Okay, you have a list. Any collection list you can pass parallelize function, it will become RDD. So what is the difference between the one collection, normal collection or parallelize RDD? So when you apply parallelize function on your collection, it will become distributed immutable collection, and that will be treated as a RDD. Okay. So RDD is nothing but a resilient distributed. So the quality of the RDD will come when you make it your RDD, when you make it your collection parallelize. So I will show you right how to make it your collection parallelize. So all the RDDs code, all the RDDs like you make it by parallelize. Okay. Or you are reading the spark.read.text file, that is also becoming RDD. So either explicitly you call the parallelize function or you can read the file as RDD. So these are all the RDDs programs, right? You see the read RDD from the CSV file. So I told you, right, RDD can be made for anything, right? Okay. Same like a data frame you can make for anything, right? Even for the structured file or non-structured or unstructured file. So, but the operation of the RDD is row by row operation. So here is the one CSV file you are reading. So you are saying here sc.text file, and you are reading the RDD. This is RDD now. Right? Either you write spark context or you write sc.text file. Both are same. Basically, it is just compact form, right? SC like they have made spark context. Okay. Or spark dot also text function is there, right? Your text file function is there. That also you can spark dot read dot text. That is also good. So you are reading some CSV file. In the CSV file is there in SRC main resources. So resources folder, they have given this data. So resources are having chip code non header, no header. So this file. So this file is a CSV file, right? Comma delimited file is there. This file is a CSV file. And this file I'm reading as a text file and I'm getting RDD. Then I'm applying the operation here, rdd.map, row by row I'm doing. So what I'm doing, I'm splitting 0 column, 1 column, second column, third column, right? Like this. Index basis, I'm getting the data. So when I run this code, I will see my data will be coming. and I'm just using the for each is the action, I'm printing the city name. So for like 10 rows are there, all 10 rows, I will print the city. So what is the column name city? City is here, city dot 013. It four has this is from RDD2, they are making it as a RDD of the zip code type, and whatever row they are forming, they have this zip code is a class. So when you click on this, so splitting string is there. Okay, so it is not going on. So this is some split string. Okay, it is defined here. Split string is basically it is splitting the row. It is splitting any row, any string. It is converting into the array. So when you do row dot split, comma, it will become array. Then the number of values will become array. And then it is taking, each individual value is as a zip code. So, zip code is a case class here. This is a class. Zip code is a class, right? I'm saying, okay, this first one is the pin code number, this is a city number, this is something like I'm saying. Yeah, I think this is still not doing. It's still is indexing the thing. So one case class should be doing. Okay, so this is like one example. There are many.
Is the zip code, excuse me, the zip code, is it not a constant? Or
So RDD is operations, right? Like you can create a manually RDD by using the parallelize function. So suppose I'm creating a two columns RDD. Two columns RDD I'm creating. Like I'm saying it's a sequence of data, right? Some skills I'm saying, and what is this skill like second column. Right. Okay, something is there. This is a number column. We can understand this is a 220,000. This is a 100,000. So just we are talking about the salaries of the this particular technique. So I'm getting one RDD and I'm doing println. I can print the data of this RDD. Or second RDD I created reading from the file. But this path it will not read. We have to give some proper path, right? Because this text file is there. File text file, there is no file, such file is there. I think we have to do another one, right? This particular, there is no PAT path. So you give always SRC main resources and then with the any file.
Maybe it's giving that as an example. Maybe you have a local part and a text file, isn't it? Well,
Operation, the doing individual element of the RDD I want to get, right? So row dot underscore one, row dot underscore two plus one. So first we have to check the data of similar data, the file, then we can do this stuff. So elements file should be there because we are getting the two elements. Dot file name and file content. We can run now because the main function is there. So right click and we can run. This is one the example of the zip code one. This is zip code one. We are reading the zip code, no header file. See, this case class is there. So I told now record city. So which column is the city column? The 0, 1, 2. This index column is the city column. Okay. So this case class, we are mapping the data into case class. The RDD data we are mapping into case class. Okay. So here I am just mapping into the case class. And wherever the city is there, it will take its city, right? When I say a dot city, so my city is, which one is the city? City is my, which number of column is city? So my city is 0, 1, 2, second, this column, third column is city. So wherever I do a dot city, so all the rows city values will come, every row. If I do a dot state, so state value will come. So same thing if we do in the data frame, it is much easier, right? I will read my CSV file and I will say data frame dot select. If I do instead of this one, if I just same thing, if I want to write for the data frame, so what I need to do, if I want to do this all 3 lines of code for using the data frame, so simply CSV file I will read as a spark dot read dot. Okay, I will read this is now my data frame. I will read the data frame, and after getting the data frame, I will do df dot. But it depends, right? Whether we have the city, this non-header column, there is no header is there. The first thing is how to come to know header. See, this is all city names are coming. Okay, so only 20 records are coming. But if you want to get more, so depending on the data, so it is showing the all the city names. So if I do the same thing with the data frame, so I should have the header. Otherwise, what I need to do, I have to add the 2df and add the header. because header I have to, or I have to add a scheme. Okay, if it is already not there column name, so I need to define all these columns. How many columns are there? One, two, three. So all these columns I need to define because I cannot get the city column without giving. So my city column is this path. This column is the city column. This one. Mm, mm. So in the CSV file, I have to change it to the column name, right? This is the first column. So I say column. This is the column two. Even though these columns I'm not using, but I have to, I have, because I'm reading entire file. I'm reading entire file. So how can I get my city column? So I have to define all the columns, like column one, column two. So, or if it is the same columns are there in the file, then you can read with the header. There is a dot header option is there, option. You can pass the option here, header. When you say header, then it will be reading the city column. Then you can do directly only spark.read.csv and then dot select, you will get the city column. So the column. Even though value is not there, but I need to define the column. Now I will be here dot select. So start here with the this RDDs you start first and then RDD is also having the same functions like sort by their word count is important. Because CSV file we can give the folder. So if I give to have more than one file, so we can give the folder path, it will read all the files. Here is an error is coming in the column is not making. So see, our old column name is saying 20. So it is expect. Okay, new column is 13. So still my columns are not sufficient. So at least column mapping should be important here. So which column is the city column? Because maybe the one row we are checking the data that is this one. This one maybe is not 20 column. 20 column is the max column. So, so when we define the all columns, then we get the The number of column doesn't matter. Or better, we can define here in the header column. See this one we can take it. This is the one. This is the location text. Now we read this file with the header. So this code read from the CSV file will read with the header. So we don't need to use this. So now header is there. The okay. But city column is not there. So you have to see what is the column. City is there. City is there. So the column name should be correct, right? So otherwise it will not give the error. So because you will get error at the runtime. So header 2 will be reading file with the header. What is so 1, 2, 3, 4. City is the fourth column. So RDD is one I commented. Now you can see, now I'm getting the city. Okay, so data frame operations when you're doing, right? So just it is not able to recognize the because it is trying to do string value, the first one, and converting integer because RDD is reading as a string data and converting integer. Okay, so it is a problem because the first column, the first row you inserted one string, right? Okay, the very first row in RDD, so you should not use the first row because first row is becoming your header and header is having the string data, this is string data, this one. So that's the reason they use no header because no header, they will create a RDD and then they will assign the header when they will iterate the data. But when I'm trying for the data frame example, so the header is there. And because of the header, this is a string value. So it will break, right? It will break. So that is the reason why you are trying to run a same code, right? So same data for RDD or data frame, it will give the problem. Okay. So for RDD case, you don't keep it any header, right? Because it's a string value. Okay. If you don't do any operation here, like this, don't convert to int, so you will not get the number formatted. Just to keep it as it is, string value you take it. Don't take it as it. So I'm not doing any calculation on this number. Right? If I'm not doing any calculation, I can take it as a string value. Okay, but again here in my case class I have to change. So I will go to my case class and case class I made it here a string into the class. It will run now. Okay, so the okay, you guys understood this thing? Oh, there are many places it is used. Okay, so it will be boiling. Okay, so this is the another file, sort by color. Okay, so all those files is breaking. Right, so because we are using the same case class. Sometimes now you change a different case class, so don't modify the one, otherwise it will impact all the one. Now the code will work fine. See now you are getting this is a data frame operation and where we are printing the RDD. So we have now if I print, so first will come RDD result and second one will come. Okay, so this is a data frame result and this is the RDD result. So both results are same. So here the code is working for, oh, sorry, this is the RDD result. And this is, let's connect tomorrow. Okay, so you will have the question. Okay, thank you.